All right, and hello and welcome again to another one of the ZEISS Micro Minutes live. This is an episode that I'll be showing the rapid large area laser milling of battery materials. My name is 𝗦cie𝗰𝗶𝗹𝘀. I'm an applications engineer here at the ZEISS Microscopy Center in Dublin, California. And you see our building in the background here. So today, like I said, I'll be going through how extremely useful and powerful it is to have a laser that can mill millimeters of very large amounts of material, both in width and depth. And I'll show you some examples of those as we get along here. So what I'm going to start out with first is to show you some example of what the result that we see here. So I'm going to switch to the monitor here. So on the left and the right, we see a low-mag image of a tilted cross-section of an NMC battery catalyst material, cathode material, that has been milled. And you notice that the micron marker, so the full width is around 500 microns. And in the right-hand image is just the magnified image of that. So this is what I'm going to show you how we got to, but this is the result, and this is how large of an area that you can mill and how extremely nice it is even after the laser milling without even using a focused ion beam after this. Next up, I'm going to show you the tool here. So this is our Crossbeam 550 laser tool. It has a 𝗶𝗃 beam that's off to the side here. It's got a SEM beam that's on the column. It's a Gemini 2 column that has single apertured condenser. And then on the right-hand side is the important part that we'll be going through today. So the laser is on the right-hand side. It's mounted on top of the load lock. And the powerful thing with that is that any of the material that's going to be ablated, which is quite a bit of material when you're doing laser milling of large areas, it's all going to be captured within the in the load lock. So it's not going to get your chamber dirty. It's not going to get anything in your detectors or your stage or anything like that dirty. And what you do is you laser mill within this chamber, you put it back in the SIM, you SIM image it, and you can go back and forth between them as you need to do either laser milling or fib milling or imaging with the SEM beam. So the next I'll show you zoom in view here. The load lock is actually down here and the laser module is on top of here. That's just mounted on top of the load lock, our standard 80mm load lock. If we open up the load lock here, this is where the dovetail is, and you put the sample in. I'll show a video in a moment here. On top of this, it's a key thing. That's a piece of glass that is in between where the laser is and where the sample will be. And that will keep any of the debris from the sample that sputters off of it from going up into the laser. And you can just clean the glass in between periodically or whenever it needs to. It's very easily done. The next thing would be the shuttle, just to take note of where the shuttle is. So this shuttle, you can put the sample on any of the positions here. These right here are the fiducials, and these are what it will use to keep track of it. And I'll show that as we go along in the workflow on our, it'll first do it in the SEM beam, and then it'll register it, and then it'll do it in the laser and register that, and then it'll correlate the two together so that everything is synchronized. So what I'll do now is I will go back and I'll go ahead and start playing a short video that I took of me putting the sample into the load lock. So I have it here. You can see where if I pause that there's a sample here, and then we got the shuttle. And I'm going to put it on the dovetail that's inside the load lock here. Just putting it on there and taking off the extension rod for that. And I'm going to quickly show you that you just pop off the glass here, check to see if it's clean. If it's not, you just clean it with a chem wipe or something like that. And this one's clean, so put it back. And then we'll close it up and pump it down. And then we'll be ready to start the process. What I'll do next is there's a video that our marketing team created that is really good, and it's a CAD simulation showing the laser milling workflow. So to give you some idea of what it's doing, it's a little easier to see with the CAD schematic. So you first load the sample in here, and this is the stage, the middle of the stage. There's a fib column that's coming in at 54 degrees, and the SEM column's coming straight down on the sample here. Samples in the middle, and then the fiducial marks are here, 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 and here. And you can have up to 4 stubs here, or a larger, bigger stub in the middle, whichever you choose. So then it takes images and notes where these fiducials are, and it makes a coordinate system with regards to the SEM beam. And then we take it out of there, pull it back into our chamber where the laser is, and then it's going to scan the same fiducials with the laser. And now the coordinate systems are locked together, so anything we do in the SEM, we can tell it to the laser where exactly to mill, and in this case it's on an edge. This is an arbitrary semiconductor sample, which we won't talk about today, but it's the same idea for any sample that you want to do. And then we put it back into the chamber, and at this point we have it where this is the size, and this was done on, like I said, a semiconductor sample, but it's millimeters in size in X and Y. The amount of material ablated was in the millimeter depth range, so 1,000 micron or so. It's pretty easy to do. Usually takes a few minutes is all to do on those. So it's much, much faster and takes very little time to take a lot of area and a lot of material and ablate that. So next I'm going to go through the workflow. So I'm at the tool here. I'm going to look. The NMC sample is actually here. It's offset. It's not in the center of the stub. We're looking top down. There's some grains here. And we see, I'll go ahead and make the live image here. Just give me a second here. There we go. And we see it's a live image. We're looking top down. And it's just a NMC cathode. We'll pick an arbitrary area somewhere within here to go ahead and use that as our laser milling target. And then you tell it to take an image, and it takes an image. The information that we send over to here is going to be used by the laser. So the Smart SEM interface, if you've seen it from ZEISS, is on the left, and that controls the SEM beam and the imaging parameters. And what's on the right here is the laser parameters. So we just send an image over to the laser, and it registered where the coordinates are, and it'll save that. And then eventually I'll show you that we'll send that to the CAD milling program that's used for the laser. So if we continue on here, we're going to tell it to drive to the first fiducial, and it's going to register that. It'll move over there and take an image of it. It's a hole that's in the fiducial here, and it's very well centered. If it weren't, we could center it a little bit better, but it's just registering where the center of that is in the image. Note that it turned green and indicating that that's a good match, and it'll move. I'm going to go ahead and skip the next two, and we'll bring it back in here on the fourth one. So it did 2 and 3, and it was successful with that. Doing number 4 here. Once we get these, then it has a lock on all of those in the SEM, and then as we saw in the workflow, we'll pull it out and put it into the load lock chamber and let the laser have at it. So there we go. We're back in the laser. One thing to note here, let's go ahead and back it up a second here. You can see an image in the laser chamber of the sample here. So what we have in here, the battery is actually in the middle here. So I'm going to have it scan all. So one thing that you'll see that there'll be tiny little bits of light. They're almost imperceptible. That now it's at the bottom left, now it's at the bottom right, and it's at the top right. So it got all those, and it registered those. It's all green. So we have a lock in the coordinate system between the SEM and the laser at this point. Now I'm going to open up the CAD. So click on a CAD program. The layout that I'd saved earlier that's useful for battery materials here. In the CAD program, it shows the shape of what we're going to cut out. and then it shows, you can see a number 3, and that's where the third fiducial is located. If I were to zoom out, we'd see where all the fiducials and where all the stage locations are. So I went ahead and I pulled an image in. The image that we took, I told it to bring it into the CAD. I'm going to zoom in on that, and I'm going to pull the milling box over here. The milling box is comprised of 3 different, there's a coarse one, there's a little bit less coarse one, and then there's a fine polish at the end, and they're colored differently. One of them, the coarse one's blue, the next one will be red, and the magenta one is the fine polish. And each of those have different power settings and scanning parameters, much like the fib, the gallium fib, but it's just that it's a laser. So it has cycle at a hertz, and it has hatching parameters. So this is where you access all the parameters. I'm not going to go through those today, but you have access to all those, and it can be saved out as different recipes, which we saved them in this case for the battery materials. We know they work well. We can just change the power or the length of time that we want to do if we need to do that, but I already pre-tested these and they work. This is just to give you a sense of how easy it is to bring it in, and now that we have that all set up, then we can tell it to start milling. So we press start and the laser starts milling. It's very bright. You can see it live. This will take, I've spread this up by a factor of 2. It took, I think, 2 minutes and 15 seconds total for this one. I didn't want to belabor this, but it does show you where you can view it live and see what it's doing. And this is just the rough bulk cut that it's doing initially, which in the CAD we had seen that it was the blue hatching area. Give it another 30 seconds, and then it'll transition to the finer polishing steps. So anything within the field of view here, you can mill. I had milled on, this was a piece of steel that was in the middle. There's different things on that as well. And then there was another sample. I don't remember exactly which one, but it was over here. So any of those areas that are within the CAD's ability to mill, you can load in all simultaneously. You can register them in the sim, and you can mill them. You just pull in different mill boxes and assign them different recipes. All right, now it's changed to where it's doing a single line on that front face for the final polish. We're going to put it back in the sim. Let's go ahead and load it here back in the sim, and I told it to go back to the site that we were milling, and you just do that using the button here, and it goes right back to the site, and it turns the EHT on again. And this is what we see when we initially look top down. So it's done the bulk cut here, and it's done, it has a nose. I did a bull nose shape because that kind of prevents any sputtering, major sputtering from the bulk cut from going on the face, and it also helps to cut the final polish. This particular type of shape works really well in different materials and samples. I'm going to go ahead and make it live in a few seconds here. And all right, now we're looking, I tilted it, looking at it in cross section. I'm going to go ahead and zoom in a few seconds here, and we'll take a look at some of the grains here. The objective is to look at the porosity and some of the grains and the structure of it. There we go, looking at, and it made a really nice cut. Minimal amount of curtaining, and we really don't need to do any fib milling at this point, and it looks good enough to do the analysis on and take images. And we have a very large area that we did. It was at least 0.5 millimeter, if not 3/4 millimeter. All right, so one thing I want to do is go back. I'm going to go ahead and show you some results here. I will go ahead and do this guy. So You can see some results. This is what we saw, and the top down is on the left, and the tilted is on the right. And we see that the field of view width of the image is around 2 millimeters. So, this area that's been milled out is at least a millimeter by millimeter area, and it's at least 500 to 1,000 microns deep. If I click on this, we see that it's really nicely milled, and you can see the imaging of it. If I go to higher mags here, then we can see that we can see the grains, the straight grain structure, the porosity, and easily identify things that we need. And this was all done just within a few minutes. I mean, we don't have to spend hours like we would on the gallium fib doing this. This is much faster even than a plasma fib would be. And if I do even higher mag here, just to give you an idea here, this is the quality of images you get in just a few minutes when you're using a laser mill. And you can investigate over a very large area and take more statistics than you would if you were doing just a small area with the gallium fib or anything like that. And that's the end of what I have for you guys. If you guys have any questions, you can put them in the comments that are within the, let me go ahead and minimize this and bring up my interface, because I can see if you have questions, you can put them in the box that's in the YouTube link for the live streaming. It looks like nobody has any in there right now, but if there were, I can see them. And if not, these are the QR codes for our workshops that we do. We do paid workshops that you can attend. There's a ZEISS portal that has different videos on it that are educational and tutorial videos of light microscopy, X-ray microscopy, and electron microscopy, all kinds of microscope and different tools and software that we offer. And that's a very big benefit for those of you that have ZEISS microscopes. The live streams, if you look at the QR code on the right, there is not one next week. Just note that because of the Thanksgiving holiday, there's not one next week, and it'll be similar for the holiday break at the end of December. But in between, if you go on our link, you can see what the upcoming streams are. Let me just check one last time and see if there were any other questions. If not, doesn't look like it, but if you did, you can go ahead and you can email us at any time. We're applications at the ZEISS Microscopy Center in Dublin, California. And with that, I thank you for your attention, and I hope you have a nice day.